Since it first opened in May 2007, the Creation Museum has been an important teaching experience for over 1 million visitors. One of the museum's most popular exhibits is the Stargazer's Room, a planetarium dedicated to the glory of God. The planetarium originally used an Evans and Sutherland Digistar 3 system with center-mounted standard resolution projectors. In 2010, new technology and funding allowed us to upgrade to a Digistar 4 system. This new state-of-the-art system features cove-mounted, high-definition projectors, which produce much brighter and sharper shows than the original design. Also, the new Digistar 4 software and faster computers allowed us to upgrade our most popular planetarium show, the Created Cosmos. Some of the improvements were built into the new software, such as better star fields and higher resolution output. But I made a number of improvements to the show as well, thanks to newer scientific data and more powerful computers. Let's take a look at some of these changes. The model of the International Space Station is significantly sharper in the special edition. The solar panels now simulate the reflection of Earth. You may notice that the star field is much improved as well. The new software makes it easy to add a faint, translucent halo to stars or any other object, which makes them really look like they're glowing. I redesigned the Earth model so that it would make the best use of the new software. It appears more vibrant than it did in the original release. Most of the camera angles and movements remain unchanged. The journey to Alpha Centauri has also been improved. In the original version, the speed is so fast it often exceeds the frame rate of the computer, and that makes it look like you're standing still or perhaps even going backwards. So in the special edition, I added a little X to every 10th box, and I also changed the color every 100 boxes. This improves the sensation of motion. I also was able to increase the smoothness of the journey by implementing a mathematical algorithm that brings us to Alpha Centauri just exactly as the speed goes to 0. It makes for a much smoother ride. The constellations look quite a bit sharper in the special edition. This is because their lines are anti-aliased, and so you don't see the pixelation that was evident in the original release. In the original version, I avoided using warm colors like red and orange because they just didn't show up very well on the dome with the low power of the original projectors. But since the new projectors are quite a bit brighter, there was no problem making the constellation lines orange. Now for the models of the stars, one improvement that was made in the special edition was to add a bit of brightness to the center of the star, and that was easy to do with the Digistar 4 software. This created a wonderful effect. First of all, it made the stars look a bit brighter and more vivid than they did in the original. It really makes them look like they're glowing at this point. And secondly, it creates a phenomenon called limb darkening. And that is not only artistically attractive, but it's scientifically accurate. That is, stars, the sun in particular, exhibits this phenomenon where the limb, the edge of the sun, looks a bit darker than the center of the sun. And the reason for that is stars are made of gas, and so you can actually look into them a little bit. They're not solid, they're translucent, and so when you look to the center of a star, you're able to see farther into its core where the temperature is hotter and where the star is brighter. Then when you look at the periphery of the star, where you're skimming along the surface, and the temperature there is cooler, and so it's a bit fainter. Limb darkening really improved the look of the stars in the special edition. The journey to Orion's belt is a great place to compare the star fields between the original version and the special edition. You can see that with the special edition, the stars seem to be glowing a lot more strongly, and that's because of that translucent halo that's been added around them. And that causes the stars that are bright to look really, really bright, and it's easier to tell the difference in brightness between two stars, whereas in the older version, they all sort of looked about the same brightness. The difference was less noticeable. The journey from Orion back to the solar system really showcases the improvements that have been made to the star field and to the constellation lines. It also shows how the animations have been touched up in the new version. They're just a bit smoother and less clunky than they were in the original. The special edition includes not only artistic improvements, but scientific updates as well. For example, the original release marked the positions of 80 extrasolar planets. However, we have discovered hundreds more in the intervening years. As of this video release, we now know of over 500 extrasolar planets. Each one of these is marked in its true position in the special edition. The Upsilon Andromedae system is another example of updated science. Initially, it was thought that the 3 planets were roughly coplanar, that they orbited around their star in roughly the same plane. However, more recent research suggests that the orbits of planets C and D are tilted relative to each other by about 30 degrees. This new result has been incorporated into the special edition. The improvement in the M4 globular star cluster in the special edition is quite striking. This was made possible because of the glow that we were able to introduce around stars in the Digistar 4 system. Additionally, I stretched the colors in the new globular cluster, making it easier to see the distribution of red and yellow stars. Globular clusters contain very few blue stars, and so those weren't included in M4. In reality, the color of stars tend to be kind of bland. They do go from red to blue, but it's a rather pale blue, and even the reddest star is not all that red. So it was an artistic choice to stretch the colors as they're seen here, but it makes the color easier to see in the planetarium. This new representation of the M4 cluster clearly gives one the impression that the night sky of this extrasolar planet would be incredibly beautiful. I made only minor improvements to the model of the Milky Way galaxy in the special edition. These included the brightening of a star dot model field, which was present in the original release but was hardly noticeable. The brightening of this field in the special edition made it very clear that this is a 3-dimensional galaxy, and it also helped it to look good from an edge-on perspective. Additionally, a slight glow was added to the Milky Way galaxy so that it would match the other galaxies in the background once we zoom out. Perhaps the most substantial improvement in the new version, at least in terms of my contribution, is the new galaxy field. The new mapping of galaxies is based on newer data, and so a lot more galaxies are present in the newer field, and I've made use of the new artistic abilities of Digistar 4 to add that beautiful glow around objects that makes them look like they're really bright. Additionally, as with the M4 star field, I increased the color range of the galaxies a bit beyond what it would be in reality, but that's so you can identify which type of galaxy is which. Blue galaxies are spirals, red or orange galaxies are ellipticals, purple is irregular, and white is unclassified, at least in terms of the data sets that I had access to. This is somewhat realistic because, of course, spiral galaxies do have more blue stars and have a bluish tinge to them. Elliptical galaxies do have a reddish tinge to them, and so on. But I have exaggerated the color so that you can clearly identify the type of galaxy. This color scheme was also available in the original release, but it was more subtle. I tried to make the galaxies look more realistic, the way they would look to the unaided eye. And the problem with that is you really couldn't see any color at all in the original release. Once we get significantly far away from the Milky Way galaxy, the data set is based primarily on the Sloan Digital Sky Survey, and so I don't have information on the Hubble type of galaxy, and so they're all colored white at this point. The original release was based on the Sloan Digital Sky Survey Data Release 2. The special edition is based on Data Release 8, and so there are a lot more galaxies in the special edition. In the original release, only certain wedges of galaxies were visible because we'd only mapped certain regions at that point. In the special edition, we've mapped much more of the universe, and so most of the wedges are filled in. Now, there are still a few missing wedges even at this point, but this is one of the few places in the program where I changed the camera angle so that you can no longer see the empty regions, the regions where we have not mapped galaxies yet. Part of the reason for doing that is I found a lot of people had questions as to why the universe had all these wedges built into it. Well, those are artifacts of the fact that we've only mapped certain regions, but I avoided that whole question by picking a better angle in the special edition. The zoom-in sequence is pretty similar between the two versions. The main difference is that the special edition has a much smoother animation. It no longer starts and stops in a jerky fashion, but it slows down gradually and comes to a stop, very similar to the algorithm that I used with the Alpha Centauri, the new sequence. Some very subtle changes were made to the solar system, including the brightening of the sun, and the moon is now visible in orbit around the Earth. Additionally, the final shot of the Creation Museum has been improved to reflect the many changes that have taken place to the Creation Museum over the last few years. The special edition was a lot of work, but it was also a lot of fun, and so we hope you enjoy the results.